This is Dr. S. Mohan Lakshmi, Professor and Head Department of ECE from Rohini College of Engineering and Technology. So, in this lecture, we will see about the horizontal architectural approach for IoT systems, as well as we'll see one of the type of architecture, which is SOA based IoT middleware. So, on completion, the student will be able to understand what is the need of horizontal architecture approach instead of vertical, and they'll be able to describe how this is structured in IoT systems, and they'll be able to explain the function of each layer, and they also will be able to explain what is SOA and how that has been structured. So, horizontal architecture approach for IoT system. A systematic implementation of IoT ecosystems is usually based on a layered architectural style, which can range from data acquisition layer, that is perception layer, which is at the bottom, to the topmost layer, which is application layer, which is at the top. Layers from the bottom usually contribute to devices integration and data capturing, while layers from the top are responsible for data distribution and utilization by the IoT application. The common architectural approach largely used by the current IoT system is vertical strategy, where each application is built on its proprietary ICT infrastructure and their dedicated physical devices, so which will lead to an unnecessary redundancy and increase of cost. That's the reason vertical strategy is overcome by the horizontal approach. So, whereas the horizontal approach, it is where a common operational platform is able to manage the network and the application services and abstracts across a diverse range of data sources to enable applications to work properly. So, horizontal IoT middleware approach. So, applications no longer work in isolation and share infrastructure, environment, and network elements by means of a common service platform. So, you can see in this picture, this is actually the horizontal approach where you can see three layers over here. One is perception layer, the second one is transportation layer, and the upper layer is an application layer. So the application layer consists of application and the middleware platform, whereas in the transportation layer you have all the gateway access as well as the network. Whereas in the perception layer, so as I have mentioned already, it is all with the devices connected or devices integration. So that is shown over here with the respective protocols to connect to the transport layer, something like IEEE 802.15.4 or some other Bluetooth, Zigbee, whatever it is. So this is basically the horizontal approach of architecture. So as I mentioned just now, there are three types of layers, okay, or you can say it is an interaction phases in which the cyber physical world interaction should take place. So first layer, that is the lower layer, is perception, second is transportation, the third one is application layer. So in the application layer, you do all the process management and the utilization phases. Okay, so each layer is characterized by different interacting technologies and protocols and has different purposes and functions. So the perception layer, it is almost with your devices. Management is the middle one where it will form a gateway, and the third one is application layer where we will be trying to extract all the applications or whatever the outputs we require. So the perception layer, it refers to the procedures for sensing the physical environment. It will collect the real-time data, and if you want, it can be restructured to a general perception of it in the virtual world, that is in the system logical domain. So technologies such as RFID, radio frequency identification tag, okay, and sensors provide identification of physical objects and sensing of physical parameters, while the technologies or something like IEEE 802.15.4 and Bluetooth are responsible for data collecting. So here we have two things. One is something related to the physical object. The next one is related to the technologies involved. and the transportation layer. So it includes mechanisms to deliver the collected data to application layer and to different external servers. So methods are therefore required for accessing the network through gateways and heterogeneous technologies. So something like either it could be a very normal wired connection or a wireless connection, which is quite famous, as well as the satellite. Okay, so which is used for addressing and or routing. Coming to the top layer, which is the application layer. So it deals with all the processing, analyzing information, forwarding the data to application and services, and providing feedbacks to control applications. So in addition, it is responsible for critical functions such as device discovery, device management, data filtering, data aggregation, semantic analysis, and information utilization and distribution. So indeed, these functions are essential for IoT ecosystems, and as such it must be handled by an IoT middleware platform. So coming to one type of this horizontal approach is SOA based, that is service oriented architecture based IoT middleware. So this is set of principles and methodologies for designing and developing software in the form of interoperable services, usually over the net, that is internet. Services comprise unassociated, loosely coupled units of functionality that have no calls to each other embedded in them. So SOA, or the service oriented architecture, it consists of components which are implemented as independent services. So that could take a dynamic bond, or and it could be orchestrated, and which possess a loosely coupled configuration while the communication between them use messages. So this shows you the structure of the SOA based IoT middleware architecture. So you could see, as usual, three layers will be there: perception, transport, and application layer. And you could see all the type of the sensors, networks, what it is used. And here you can see the security aspect at the end, and this services provision, management code, and devices abstraction form the exact SOA based IoT middleware. So this is a software layer or set of sub layers which is interposed between technological, that is perception and transportation layers, and application layers as shown in the figure above. The middleware ability is to hide the details of different technologies, is fundamental to exempt the programmer from issues that are not directly pertinent to her or whoever is working right with the architecture, which is the development of specific applications enabled by IoT infrastructures. In this way, IoT middleware has received much attention in the last few years due to its major role of simplifying the development of application and the integration of devices. So hope this lecture would have given you some insight about the horizontal approach and one of the middleware we have used, that is SOA. And the student, at the end of the session, you will be able to differentiate the horizontal approach and the vertical approach for the IoT system. You will be able to explain the function of each layer in the horizontal approach, as well as you could able to list the advantages of horizontal approach, and you also will be able to explain what is SOA based IoT middleware. Thank you.